In this video we're going to take you through VoIP.Master Mass Call Mode. Mass Call Mode allows you to make up to 200 simultaneous VoIP calls and to measure the VoIP quality of those calls whilst they're in progress. Mass Call Mode is very similar in principle to the standard VoIP.Master Call Mode, but because of the number of calls that we have in place at any one time, the user interface is a little bit different. As per the standard mode, in Mass Call Mode we can emulate the user's equipment, PBX emulation mode, or we can emulate the network ITSP emulation mode. In this video we're going to concentrate on the PBX emulation mode. In this mode we can look like a PBX or VoIP equipment on the user's site, and we can make up to 200 simultaneous outgoing calls, or we can support 200 simultaneous incoming calls, or any combination of the two. In this mode we're connected to the network, normally through a router connected to a SIP VoIP trunk which is connected to the network. So we're going to go to the VoIP.Master desktop and the main application screen, and for the Mass Call Mode we have a separate emulation box here called PBX Mass Call Mode with a number of profiles. It doesn't really matter once again what profile we select, we're just going to select a default one for the moment, and this will take us into the Mass Call Mode workspace. Now the Mass Call Mode workspace is different from the standard call workspace, and that is because in the standard mode we display all the terminals up to 30 so you can see the status of every call that's taking place. Because in Mass Call Mode we can have up to 200 calls, there is too much information to display at once. Also, this is very intensive, so we use a different display mode, basically showing outgoing and incoming calls in the form of a graph. Now one of the nice things is, if we've created profiles in the standard mode, we can use those in our Mass Call Mode as well. So in a previous video we created a configuration for PBX emulation mode. What we're going to do is we're going to click here on the load button and make sure that we change the profile to what we call CVS, which is our standard mode of operation, and we can see here a profile that we created previously. What we're going to do is open that profile, and that will load all the configuration settings from the profile we created in standard mode into the Mass Call Mode. Now what we need to do is we need to now save that profile, but this time under what we call the MSP profile. So we're just going to give it a name. I'm just going to call that VM Test 1 for simplicity. So now the profile and all the configuration settings are stored in the Mass Call Mode profile, but we probably want to change some of the settings. So we're going to go back into the Configure tab, but just to check that everything is the same, we can click on Trunk Settings, and we can see here that the ITSP address we had previously is the same in the previous video. The registration, authentication, username and password are all the same. So it's pulled all this information in, but in the test settings we want to do something slightly different. In this case we don't have all the different modes of operation, we just have one call mode in Mass Call Mode, but we can set the number of terminals we want to do. So for this example we're just going to make 100 calls. We want to make those calls fairly quickly. We can change the delay between each call being set up, but we're just going to change that to 50 milliseconds. So it's going to make one call, wait 50 milliseconds, make the next call until 100 calls are in place. The operation on connection is we want to send a WAV file, so every call that's being made we're going to send a pre-recorded message, audio on RTP out to the other end. And essentially that's all we need to do. And if I click on the OK button now, I can start the workspace, and VoIP.Master will start the protocol stacks, and we can now see that we've got a registration status is registered, so we've registered with the far end. We're ready now to make our calls. So what we can do here is very simply is click on the call button, and what you can see here is in the corner here is the number of calls being set up. So very quickly we can see there are 100 calls in progress. They're all good calls, there was no busies or no answer from the far end, so we've got 100 calls in progress. And this graph here shows a running total of the calls as they were made. Now we can clear these calls down if we like, just by clicking the hang up button. And we can see now that there are no calls in place, and everything's been, all the calls have been cleared down. Now we can just run that again if we want. So let's make another 100 calls. And here we have those calls in progress. Now, if we had incoming calls from the other direction, these would be showed in this graph. So as we say, we can have 200 calls in total, either 200 outgoing, 200 incoming, or any combination. So we've made 100 calls here. We could have another 100 calls coming in. So I'm just going to hang up those calls once again. Now we've got no calls in progress. And what we're just going to do is stop the workspace. Now, what we can do is we can do a number of things here. We could go and look at the results for that test, but we'll come back to that in a moment. What we're going to do instead is we're going to go back into the Configure tab, and we're going to quickly set the Test Threshold tab here. Now, this allows us to set some test thresholds so we can have a pass-fail criteria on the test. Now we can do two things. We can include the quality of service, or effectively the MOS score, on each of the calls that are being made, or we could include the number of calls made. So for example, we could say we want to, if we're making 100 calls, we want to make sure that 100 calls are successful. So we're going to set the call threshold to 100. We're going to include the QoS test, but we're going to make it the MOS. And we're going to make sure that every call made has a MOS of 4 or greater. So basically for this test to pass, every call has to have a MOS of greater than 4, and we need to make 100 successful calls. We're now going to click OK. We're going to start the workspace again. We should get a registration status. Okay, we're registered, we can make the calls. So we make 100 calls again. You can see these calls counting up. There's 100 calls now going. We could leave that for a period of time. We're not going to wait too long. But let's wait another, say another 10 seconds. Okay, so that's clear. Now hang up the calls, and you can see that we've got a pass. So basically, VoIP.Master has detected that we made 100 calls, and the quality of all those calls was good. Let's just click that to clear that message. Now let's just stop the workspace again. Now, whenever we make a test in VoIP.Master, whatever mode, test results are automatically stored in the background, and we have a PDF test result file created automatically. So what I'm going to do is click on the Results tab here. We have two types of results, what we call stats, call stats, and trunk, which is like a trace, a call trace. So we're going to go into the stats file, and we're going to open up the last file, and here we have our PDF file with our test results. Now, at the top we have the Albedo logo, but this is totally customizable. So in the configuration of VoIP.Master, you can change the logo that you want displayed in your report, so you can make this your own logo, customer's logo, whatever you want. You can also put in the configuration some test information like name of company, address, engineer. All that information is also stored in the header. We haven't got anything set up here at the moment. We get a summary of the type of test we've run, and because we set a test pass-fail threshold, we get a pass or fail threshold in the report. And then we get some various information. Here we have the call status information. We can see here we made 100 calls and they were all good calls. We get a average MOS score and R factor for all the calls being placed. So this is an average across all the 100 calls. So this shows us that basically for that trunk, for that link, the average quality was good. We get a graph showing us the time and the number of calls that were in place, so we can see the calls being built up here, and then we have 100 calls, and then we clear them all down. And then we get individual results for every terminal, every call we made. So basically for what we call terminal 1, call 1, right through to call 100. We get the jitter, the delay, the MOS, the RTT, and the R factor. We get that for the receive side, and we get it for the transmit side. And that's quite important because it's often the case that one side of the transmission can be good, but another side may be bad. Now that may be because a router or something is dropping packets in one direction or delaying packets. It could be that the route through the network for the transmit and receive side is different, and there's some impairments on one side of the transmission. So being able to see both sides of the getting quality indications for both sides of the transmission can help you determine if there may be some problems on the transmit or the receive path. So we're just going to close that PDF report down. I said every test you make, results are automatically stored. Just going to click the results tab again and go into the trunk. And this is our trace window. And this basically is a copy of the trace window. So as calls are made, you can see what numbers we're calling, what numbers the calls have come from, were they connected okay, and were they cleared or not. So this is just a useful trace to make sure that calls are being connected and cleared properly. Now, one thing we haven't covered, but we'll be covering in another video, is that within the VoIP.Master environment, we can also run Wireshark at the same time, which gives us a full protocol decode. So as we're making tests, making outgoing tests, making incoming calls, we can capture all that information in Wireshark. You can obviously save that information to a file, and then you can even pass those files to other people so they can analyze calls. But like I said, we'll be looking at that in another video.